This is brought to you by the Alumni Association of PISJ-ES.
The third rule, let me change the color, I think I'm bored with the color. Let's take it back white. The third rule says every object or every force applied to an object has an equal and opposite reaction. Now guys, remember, force is a vector quantity. The direction is important. We have seen it earlier. Force is a vector quantity, and the direction and magnitude, both of them are important. Now let's see if this is, what does this mean? If this is a wall here and I am pushing on the wall with some force, what happens is, since this object is experiencing a force of F, this, and let's say this is me and I am applying this force, this object, this wall here, will be exerting a very similar, let's say the same, a force with the same magnitude. It will be exerting a force with the same magnitude on me, but in the opposite direction. So every object, when we exert a force on any object, it exerts a force back on us. If you've seen it when you are in the swimming pool, let's say this is the blue color, it gives the effect. If you are in the swimming pool and this is the wall of your pool, let's say this is the wall of your pool, and you are here inside the water. So if you are here and whenever you are swimming, when you reach this part of the swimming pool, you just push, like if you give yourself a push when you're just laying like this in the water, these are your feet actually. So whenever you want to move forward, what you do is you just push against the wall and you give it a force. In return, the wall gives you a force again, which helps you move forward. So the force that the wall gives you is exactly the same as the force that you exerted on the wall, just in the opposite direction. So we can always say that force given to, let's say, the wall by the man to the wall is very similar to the force given by the wall to the man, but simply in the opposite direction, and it has a negative sign. So some of my students ask me, why is it like, and even in this question, I don't need to do this, let's just say here, why is it like that I move here but the wall doesn't move? If we are experiencing the same force, why does the wall not move? Why does the swimmer move? For that, let's just take an example here. Let's say you are giving let's say you are exerting a force of 20 newtons on the wall, and this is you exerting the force on the wall, and the wall exerts the same force on you as our theory suggests. And let's say you have a mass of 60 kilograms. So let's find out what is your acceleration. So the formula, we know this, force is equals to mass times acceleration, and acceleration is equals to force divided by mass. So because of this force that the wall is giving you 20 newtons in this direction, you are having an acceleration of 20 divided by your mass, 60, which gives you a 0.33 repeating, as in 0.33 meters per second square. So this is your acceleration in this direction. However, if you are giving the same force to the wall, let's say has a mass of I'm just making this figure up. 1 times 10 to the power 10 kilograms. Let's say this is the mass of the wall. Now for the same force that you are applying to the wall, let's find out the acceleration of the wall. The acceleration is given by force divided by m. Again 20 divided by 1 times 10 to the power 10, the mass of the wall. And if you just calculate the mass of the wall, you will get an acceleration of 2 times 10 to the minus 9 meters per second square. And this acceleration is very, very, very small to be significant. It's insignificant, as in it's very much equal to 0. It's not equal to 0, obviously. You can argue that there must be a little acceleration. There might be a little acceleration, but it's so insignificant that you are not able to notice, and you might not notice that. So in calculation, you can see that the wall is moving with a certain acceleration, with little tiny acceleration, but it's so insignificant that you can't actually see that happening. So this is the basic principle behind, and this is the reason why you move and the wall doesn't move. So the 3 laws of motion are the very fundamental laws of forces, and you should have a very strong grip on this. So guys, have a good look on this video, and if you have any problems, just comment and I'll reply to them, and I'll see you in the next lecture. Thanks for watching.